Okay, everybody. So here is the review of the polar form complex numbers, all that fun stuff. Merry Christmas, because it's Christmas time in March. So, yeah. So here we go. So, first of all, first section. Finding the moduli is literally just the length of like the vector guy, right? So you're finding the longest side, or the c of the a squared plus b squared plus c squared, or equals c squared, right? So you would just do like negative 3 squared plus 4 squared, right? And then you would square root that answer, right? So 3 squared is 9, 4 squared is 16. Add those together, you get 25. So square root of 25 is 5. Don't even need to put that in my calculator. So 5 is the answer, all right? And then this guy, 2 squared, negative 2 squared. It doesn't really matter if you include the negative because everything squared is positive, right? In fact, that's usually how I think about it. So I don't even bother with the negatives. I'm not even going to write negatives. I'm just going to write 2 squared. And then negative I would just be the same as a 1, right? So plus 1 squared. So 2 squared is 4, plus 1 squared is 5. Square root of 5 is not nice. So you could write it as square root of 5, or as a decimal, 2.23, or 2.2. But I would just leave it as the square root of 5 because then I'm not rounding and I actually have an accurate number representation there, right? Same idea if they give you an ordered pair, like it's like the endpoint of the vector, so like the length of the vector is the same and you do the same things, just 3 squared plus 6 squared. Okay, 3 squared is 9, 6 squared is 36, add them together you get 45. And the square root of 45 is, I think, the square root of 45. Nope, 3 root 5. So 3 root 5 would be your answer. These are really tough, I know. It's just literally just the Pythagorean theorem. So 3 squared plus 3 squared, that's 9 plus 9, so 18. Square root of 18 is 3 root 2. 3 root 2. Okay. And then this guy, when you square a root, okay, this would be like the negative square root of 3 times the negative square root of 3. So without the negatives, the roots would cancel out, right? With the negatives, the roots still cancel out, but the negatives do too, right? So it would just become 3, and then 1 squared is 1. So 3 plus 1 is 4, and the square root of 4 is 2. And that's my answer. Okay? And then 5 squared plus 12 squared, that's 25, that's 144. So 25 plus 144 would be 169, which when you square root that is 13. Okay? These are actually really simple. I could do like a bunch of them without putting them on my calculator. Okay, then next section wants me to write them in these complex numbers in the polar form, right? So again, the polar form is z, complex number z, is equal to the moduli, or the r, also means radius if you're thinking in terms of a circle. So, for our definitions, we're calling it the moduli, right? And then times the cosine of theta plus the I sine of theta. And you should put the theta in parentheses, but I didn't there. Okay, so like that guy. Okay. So z is literally just represented by these two guys. So it's usually more than one term, right? So to do the polar form, you need to find two things. You need to find the r, and you need to find the theta. R is what we've just been doing, the moduli, right? So 2 squared plus 4 squared. 2 squared plus 4 squared is going to be 4 and 16, so 20. And the square root of 20 is 2 root 2, right? Just double checking. Yeah. No, 2 root 5. Good thing I double checked. Okay. 2 root 5 is my r. Okay, so that's one of the things I need. And then to find the theta, we have we have the adjacent, and we have the opposite here, okay? So we're going to use the inverse of tangent to figure out the degrees for theta. So we would do the inverse of tangent, and then we do opposite over adjacent. So -4 over 2. And you just plug that in your handy-dandy calculator. -4 over 2, and it gives me -63. Now, before I go any further, I also have to pay attention to the quadrants, right? So if I'm in quadrant 1, I don't have to do anything. If I'm in quadrant 2, this guy goes from 90 degrees to 180 degrees. So my degrees need to fall within that range. So if you're in quadrant 2, you're going to add 180. You're going to get a negative theta. So you're going to add 180. Quadrant 3 goes from 180 to 270, so it has to be in that range, right? And you're going to get a positive theta, so you could add 180, or you do 270 minus your theta, or you could even go backwards and do negative degrees and minus 180. But either way, you just have to follow in that degree system. And then this guy goes from 270 to technically 0 or 360, right? And so you're going to get a negative degree there in quadrant 4. You can leave it and have it as a negative degree. It'll still work because you're going backwards this way negatively. So it's fine because that would be -0 to -90. So that works if you get that. Or you could add 360 to it and do it that way. Okay? So the purposes of this guy, when I do this one, I know that if I were to graph 2, -4, I'd go over 2 and down 4 here, right? So it's going to be in quadrant 4, right? So I know that it needs to, I'm going to get a negative degree, and so I could just leave it, or I could add 360 to it. So like the two answers that would work, I got -63.43. So I could use -63.4, or if I add 360 to that, 296.56, so 296.6. Either of these answers will work and give you the correct answer when you put it into the polar form. So it doesn't matter which one you use for your theta. Both work, okay? So when I go back through and do my polar form, my r is 2√5, and then I would multiply that by the cosine of, let's do the negative degrees. -63.4, and then plus I sine of -63.4. There really is not enough place to do the work here. Okay, well now it's 28. I'm going to skip 29 because I kind of went over that, but it's the same steps even in this form. You would, again, you could rewrite this as 0 minus 2i, and just think of it the same way. Okay? And I'm going to do 30 here real quick. So again, I'm just going to do this super fast. So that I would do the r is equal to 1 squared plus the square root of 3 squared. That would be 3 and 1, so 4 squared, it's going to be the square root of 4, which is 2. So my r is 2. Okay? Then I would do the inverse of tangent is going to equal opposite over adjacent, so square root of 3 over 1. So literally just the square root of 3. So inverse of tangent, square root of 3. And I just put it as a square root of 3 because I know that's square root of 3 is just over 1 and square root of 3. Now this is in quadrant 1, right? Because I would go over 1 and up the square root of 3, so somewhere in there. So that means I don't have to do anything, right? I got 60, so this guy is 60. So my polar form would be 2 times the cosine of 60 plus I sine of 60. Okay, not too bad. Okay, then to go backwards, so this time it gives me the polar form and it wants me to put it into complex numbers. literally all you have to do here is just distribute into the parentheses there. So you would just do like 3 root 2 and then cosine of 45 to get the real number. Cosine will give you the real number, so 3. And then you would do 3 root 2 times the sine of 45 to get the imaginary number. So that one has the I, right? So I got 3 again, but since it has the I would write it as 3I. Okay? So let me show you another one. Let's do 33. So same idea, distribute the 6 into there, right? 6 cosine of 120 is negative 3. And then 6 sine of 120 is 3 root 3. So plus 3 root 3, but this one is the imaginary one, so 3 root 3I. Now, let's check. 120 would be in quadrant 2, right? That's in the 90 to 180 range. If I were to graph this, I would go left and up. That's in quadrant 2, right? So, yep, it's all good. Okay? Then this section, I'm just adding or subtracting these guys. So all I do is basically combine like terms. 1 plus 5 is 6. And then 5i plus negative 2i is 3i. And then to graph it, I would go over 6 and up 3. And there's the vector. It's pretty tough, right? And then same idea if you subtract it. Now when you subtract, you got to subtract both terms. So it just basically changes the signs. So negative 2 minus a negative 5 is like adding. So that'd be like plus 3. Or, yeah, so when you got it, you get a 3. And then negative 3 minus a negative 3 would just become 0. And I don't even have to put that because it's literally just 3. So it doesn't go up or down at all. So 3 would be right here. There's your vector. Pretty tough. Okay? And then if you're multiplying, again, you just multiply through. You got to distribute to both terms. 2 times negative 1 is negative 2. 2 times negative 2i would be negative 4i. And then I times negative 1 would be negative I. And then I times negative 2 would be negative 2i squared. We'll come back to that one. Actually, let's just do it right now. So, negative 2, and then I squared would be like the square root of negative 1 times the square root of negative 1. When you times the square roots together, the square roots go away and you're left with negative 1. So this is like negative 2 times negative 1, which would just be 2. So when I combine these, that's just a positive 2 now. So when I combine my like terms, negative 2 and 2 go away. And I'm just left with negative 4i and negative I, which is negative 5i. And that's my answer. Okay? Not too tough there. The Mabre, everybody's favorite. So just like before when we were put it in polar form, you have to find the moduli and you have to find the theta on these. So let's do this one. First of all, I can see that this is going to go left and up, so it's going to be in quadrant 2. So I'm going to have to add 180 to whatever I get before I put it into polar form, okay, to find my theta. So to find the radius, or the moduli, it'd be like the negative square root of 3 squared plus 1 squared. So this would just become 3, right? And then this would become 1, so that would be 4. And the square root of 4 is 2. So R is 2. Okay? And then it's opposite over adjacent, so it would be the inverse of tangent is going to be 1 over the negative square root of 3. So in my calculator, inverse of tangent, 1 over the negative square root of 3. Gives me negative 30. Now, again, quadrant 2, it gives me a negative 1, but I have to add 180 to it, right? So negative 30 plus 180 is going to be 150 for my theta. Now, de Moivre's theorem says that my complex number to the nth power is the same as the moduli to the nth power times the cosine of theta times the n, whatever the power is, right? Plus the I sine of theta times the n. Okay? So to set this up, it would be 2, this is to the 8th power, right? So 2 to the 8th power times cosine of 150 times 8. 150 times 8 is 1200. So I could put 1200. In fact, I will put 1200 when I put in my calculator. Okay? Plus the I sine of 1200. Okay? And then 2 to the 8th power is 256. So basically, I'm distributing 256 to the cosine of 1200, and then 256 to the sine of 1200. In fact, I'm going to write that down. 256 times the cosine of 1200, and then 256 times the sine of 1200. Okay? And that'll give me the complex number. So 256 times the cosine of 1200 is negative 128. So negative 128, and then 256 times the sine of 1200 is 221, not a nice one, sadly, 221.7. So I'm going to add 221.7, and then that would be the I. And that's the answer. Okay? Got that big old thing. So instead of like writing out 8 of these and then multiplying it through 8 times, you just have to do it once. Okay? Same idea with this guy. You would just find the moduli and the inverse of tangent. And this guy is going to be in the quadrant 4, so you could leave it as a negative degree, or you could add 360 to it, whichever one you feel better about, and you'll get the same answer. Okay? Now, last one. We're finding the distance between these two complex numbers. So to do that, you just find the difference. So you're literally just subtracting these complex numbers. So you would negative 6 minus 2 is negative 8. And then negative 2 minus a negative 3 would be like adding 3, so plus I. Now, that gives me the, I guess, the horizontal and the vertical length of the line, right? So to find the distance of that line, I just use Pythagorean theorem. So it would be like 8 squared plus 1 squared, which is 65, and then square root it. So square root of 65, I think, is just a square root of 65. Yeah. So that's the distance. And then the midpoint is going to be just you average the real numbers together. So negative 6, and I'll write it down here. Negative 6 plus 2 divide by 2. And you do the same thing with imaginary numbers. So negative 2 minus, well, plus negative 3, because you're always adding them. I'll put the plus there just so you know. Divide by 2. Okay? So negative 6 plus 2 is 4. Divide by 2 is 2. So the x-coordinate of the midpoint is 2. And then negative 2 plus negative 3 is negative 5. Divide by 2 is negative 2.5. And that is the exact middle of the difference between these two. So those would be my two answers. Okay? So, hope that helped. If you guys have any questions or concerns, make sure you ask me. I'm always here to help. You just got to ask. Also, Anderson wins, and Merry Christmas, and all that fun stuff. And goodbye.